We're going to talk about nomenclature. Nomenclature is just another way of saying naming and writing formulas for compounds. So the company that decides how things are named is IUPAC, which is the International Union of Pure and Applied Chemistry. So they are the ones making that decision. Things have changed over the years a lot, and who knows what could change in the future. And so they create that standardized naming and formula writing so that everyone in the entire world is using it the same way, okay? And we're going to have different methods for naming ionic compounds, molecular and covalent compounds, acids, and hydrates, and we're going to talk about all of those. So naming ionic compounds, again, a metal is a bond that is created from a metal, which is the cation, and a nonmetal coming together. When you write or see a formula, you're always going to have metal first and nonmetal second. So for example, NaCl, metal, nonmetal, never the other way around. So binary is pretty easy. We're going to first focus on that. So again, the cation is first, the anion name is second, and we change the ending to IDE. If that cation is a transition metal, which is that group 3 through 12 on the periodic table, or tin and lead, we use Roman numerals. And then we're going to talk about polyatomic ions, and you will have a list to reference that. So let's dive into naming binary salts. Again, salt is just a term for ionic compound. Remember, we write the metal or the cation first, anion second, and we basically just use the name of the cation first. So let's look at AlCl3. So first we write aluminum, and then we go ahead and look, and it's a Cl, so that is chlorine. And instead of writing chlorine when it is an ion, we change the ending of only the second one to "ide." So this is aluminum chloride. Okay, so again, aluminum, you write the full metal name, and then chlorine and the IDE ending. So AlCl3 is aluminum chloride. So let's go ahead and name this. So we see a K and we see Cl, so that the K is potassium, and the Cl is chlorine. But we change that ending to IDE, so it is potassium chloride. Now we're going to talk about where these numbers come from in a few moments, but right now we're going to focus on magnesium and bromine, which changes to bromide. And then we have calcium, and that is an oxygen, and we change that to oxide. Okay? So that is how, when it is a simple metal and nonmetal, we call that binary because there are two components to it, two atoms. You just name it with the metal and then the nonmetal with the IDE ending. Now we're going to write the formula for these, and that adds another step here. So again, you need to utilize that periodic table that we talked about previously that creates the ion charges. Remember, we said group 1 is +1, group 2 is +2, group 13 is +3, and then 15, 16, and 17 go down from -3, -2, -1. All right? So identify the charges by using the periodic table. And remember, we said salts or ionic compounds are neutral. We can do that by crisscrossing our charges. And again, we bring these charges down, and we don't bring the plus or the minus. We just bring the whole numbers. Now, we don't write ones typically, so this Na, which is in group 1, is a +1 charge. This P is in group 15, that is a -3 charge. We bring these charges down. We only bring the numbers, and we write it a little bit below. It's a subscript, okay? And you don't have to write that one. I'm just showing you. So let's go ahead and do this now and write some formulas. So we have barium. I like to go ahead and write this above, Ba +2. Fluorine is in group 17. It's a -1. So go ahead and I'm going to make that a Ba, and then F, and this 2 comes down. BaF2. Again, if you like to write that as Ba1F2, that's fine. I'd try to get in the habit of not writing that one because you're not going to see it like that. So K is a +1 due to what group it's in. Oxygen is -2. Crisscross, bring it down, K2O. So try these next two on your own. Now, this is a +2 -2, okay? So you can write this as Ca2S2. But when they are the same number, or they can be simplified, a 2 and a 4, a 3 and a 6, we usually end up doing that. So you're going to more see this as CAS. And you have to just remember that these are always a +2 -2. Now, I won't take points off for being written like this, but you're going to have to understand that the 2's do exist. They just canceled each other out. So this is what you're going to, I'd prefer you to write and what you're going to see. Now, if the metal, which is the first component, is replaced with something in this center section, okay, so again, this is +1, +2, +3. We're going to skip that group 14 because we don't really use that a ton. If it's this center section, or it is tin and lead. Now, there are a couple exceptions, I will tell you the truth. It's just we are really going to just focus on the main ones. You need to use a Roman numeral to indicate the charge, because the charge is fluctuating, meaning it changes depending on what it's bonding with. Okay, so this 1, 2, 3, 2, 1 charges are called fixed. So group 1, 2, 15 or 16, 15, 16, 17 never change. Okay, sodium is always +1, but anything in this center section actually does change. Okay, so there, we're going to go ahead. I'm going to just color that in. Now there are a couple exceptions, which we're going to get to in a minute, but I'm going to make sure I circle those. So the zinc, silver, and cadmium actually have fixed charges, meaning they don't need Roman numerals, but everything else does. Okay, and these as well. So anything there, we need to use a Roman numeral. I'm going to go ahead and remind you of the Roman numerals. 1, 2, 3, 4. Make sure you do IV. I don't want to see 4 lines. 5 is a V. 6, 7, 8, 9, and 10. So make sure you know those. And again, really, really important thing here, zinc, silver, and cadmium, which again, you can see, I'll zoom in here, are these. This, and this do not need Roman numerals. They are fixed charges. I actually provide you with these charges. You do not need to memorize them, and they do not need Roman numerals. But everything else in purple, you do. Okay, I should probably not have made that purple. All right, let's go ahead and try some examples here. So to write the formula of this, you have to figure out the charges, which are indicated to you by using Roman numerals, and you're only going to see Roman numerals on the first item. It only works for metals. Non-metals don't change their charges. They are called fixed, and then we're going to crisscross them down. So this chromium is a Cr, and that 3 tells you it's a +3 charge, and you have to know oxygen is a -2 charge. We crisscross these and it becomes Cr2O3. Okay, so let's go ahead and So when we're writing the formula for ionic compounds, I like to start off by writing the symbol and the charge, and again, that charge is indicated to you in Roman numerals if it is a transition metal or tin or lead. And then this is a fixed charge, and then you can crisscross. Again, you don't need to show this work. It's just something that has helped me in the past. So Fe2S3, and tin is, again, one that needs Roman numerals. And this is an example of one that when you crisscross them, they will cancel out. So you can write SN2O2, but I'd prefer, and you will only see it as SN and O, okay? Now, I showed you this here for this specific reason. SN is a +4 in this case, and O is a -2. So when you crisscross, you'd get SN2O4, and you can see these two could be smaller, okay? So therefore, you're going to more commonly see this as SNO2. You can divide each of those by 2. Okay, so this is what I prefer to see. And then we have manganese. Please don't get that confused with magnesium, with a +4 and a chlorine. And so that is a -1, MnCl4. Okay? Now, when you're naming this, it's a little bit more difficult because you have to deduce the charge. So what I mean by that is you have to kind of uncrisscross. You're going to do the opposite of what we were just doing. So let's say we have Fe2O3. You have to remember that these charges came from the opposite atom at the top before we crisscrossed and brought them together. So the Fe had the 3 belonging to it, and the O had the 2 belonging to it. Okay? So take a look at that. We crisscrossed and brought them down. So I think I made up this word, uncrisscrossing it and bring them up. Now, you have to remember the first one is always the cation, the second one's always the anion. So the reason why we have to do this is because because Fe is a transition metal, we have to know the charge to write it in the formula. If you wrote iron oxide, you would not have the correct formula. You'd get it wrong because iron has many different charges. So you have to uncrisscross to know the charge. You do not put the number that is below it. You put the number before it was crisscrossed. So let's try this. So we have Mn and it has 3P. So let's separate. Again, you don't have to show this work. I just find it helpful. So we have an Mn, we have a P. Let's uncrisscross. So this is a 3, and this doesn't have anything, so we just assume it's a 1. Remember, first thing is plus, second is negative. Now, the reason I wanted to show you this one was because this manganese is a 1 Roman numeral, and I know that's odd because I say oftentimes we don't show 1s, but you do have to show the 1 for a transition metal, because if you don't, it's almost like you forgot to do it, okay? And then this is phosphide. Now, this is one where you're going to have to kind of figure out and deduce the charges. So what is this looking like? This is looking like a 1 and a 1. Okay, would you agree? If you uncrisscrossed, it looked like a 1 and a 1. Now, the issue with this is S is a fixed charge. S is 100% of the time a -2 charge. Knowing that, you have to keep that in mind. You have to figure out what is Cu. If S is always -2, what does Cu have to be that it becomes a 1 and a 1? Okay. By doing that, you can figure out it's a +2, so you have to know that, so you can call it copper 2 sulfide. So you always have, one of them is always going to be known. You're never going to have two that are unknown. So one of them is fixed, so therefore the other, you need to figure out what it's going to be. So let's go ahead and do this. So Cu and Br, I'm going to go ahead and separate that. A Cu and a Br. Br is always -1, and therefore Cu would be +1 because no charges were brought down. So that is copper 1 bromide. So let's see, Fe, Se. So Fe is going to be iron. So let's see what our charges are. They look like they're 1 and 1, but if I find Se, it's in group 16, it's a -2 charge. Since it wasn't brought down or crisscrossed, this has to be a +2 charge to account for that. And so this is actually selenide, it's selenium. And then this one, I put a little star, the PbO2, because it is a little bit more difficult. So let me show you why. This appears to be a Pb and an O. This appears to be a 2, and this looks like a 1, right? Because there's nothing here. But the issue is this is always, O is a fixed charge. It's always a -2, always. So what does Pb have to be so that it becomes reduced to be a 2 and a 1? Another case where it'd be a +4. Okay, so this is why it's so important to write these charges and not just look what you have visually. You have to put some thought into it. Okay? Now, we're going to focus on the polyatomic ion component of naming, and this is nice because this list is going to be provided for you on all exams. All right, so you have this exact list in your lecture packet, so please make sure you refer to it. A couple things I want to point out. You are given these fixed charges. These are transition metals, and they are ones that you do not, I think I spelled that wrong, you do not need Roman numerals for. Okay, so if you see silver or cadmium or zinc, you just have to know that they are these charges. Again, you will be given this sheet, so you just have to know, don't use Roman numerals. Okay, do not use Roman numerals. And all of these are negative charges on either side, and I want to remind you that if you see a negative sign, it's a -1. Sometimes they write that, sometimes they don't. So if it's just a negative, you can assume it's a -1. Okay? So naming is a little bit more confusing for polyatomic because it's hard to kind of delineate the difference between the cation and the anion. So previously it's been easy because it's a metal and a non-metal. In this case, it's pretty similar, except it's going to be a cation, which is a positive charge, and an anion. So if you look on your polyatomic list, make sure you have that out for this section, you're going to see this NH4+. That makes it a positive charge. That means it's a cation joining with something that is negative. So you're never going to have two negatives. You're never going to have two positive joining together. And we'd call this ammonium, because that's the name of it, and acetate, because that's the name of it on the polyatomic list. So we're doing no ending changes on this naming system. So we're not changing the name ending. All right, so to name polyatomic ions, okay, you need to actually just use your list and then figure out what the two components are. And so the name for the ion, if you look at the list, oftentimes they end in ate or ite. That's not completely always true, but happens a lot here. So you're going to identify the two components, and you're going to figure out what the charge is. And again, remember, they have to be neutral. So you just have to crisscross them. And then you are going to be utilizing parentheses for these. So here we go. We have Ba, and we know barium is in the group 2. It's a +2. And we have ClO3. And so you have to find on your list that's chlorate. So when you write these charges, you crisscross them. Now the issue is when you bring this across, you're not just bringing it to the 3. So this 2 charge, when it comes down, it's not going to be 32, right? That makes no sense. Instead, it's 2 sets of ClO3. So please make sure when you're bringing a subscript down and there's already a subscript there, you use parentheses. You're never going to have 46 oxygen. So when writing the formula for these polyatomic ions, I like to do the same thing where I write the formula above it. So Al is in group 13, it has a +3 charge, and then you're going to use your polyatomic list to figure out the charge of acetate. Okay, so when we're looking at acetate, you can see on the list it is C2H3O2 with a -1 charge. Now again, same idea applies. You take your charges and crisscross them. So Al, and then that would bring a 1 down, which we don't need to write, C2H3O2, and then that 3 is coming down and crisscrossing, so we actually need to put parentheses. Okay, so Al, parentheses, C2H3O2, with another parenthesis. So copper nitrate is a Cu with a +2, and again, we can have transition metals here as well, so binary and polyatomic, so just always check where your metal is located to see if you need to write Roman numerals. And then nitrate is NO2 with a -1 charge. Crisscross, Cu and O2, and again, never 22 oxygens. You're going to have 2 sets of nitrite. Mg with a +2. Hydroxides OH -1. This is a very common one to screw up and ask yourself, do you need parentheses or not? And the answer is yes, because you're not just bringing that 2 down to the H, you're bringing it down to the OH. Okay, so anytime you're really bringing down a charge, which becomes a subscript, and there's multiple things, you're going to go ahead and put a parenthesis set around them. Nickel +1, CO3 -2, crisscross, Ni2CO3. Okay? Now we're going to do the opposite here, where we're given a formula and have to write the name, and this is where you're going to need that polyatomic list again, because you're going to have to kind of look through and see the charges and make deductions from that. So we're still doing the same thing, cation or positive charge first, non-metal or anion negative, which is second. And again, we're talking about the polyatomic. Remember, polyatomic means poly, multiple, and atoms. So everything that is a polyatomic is just multiple atoms grouped together with a common charge, one overall charge. So let me go ahead and show you how to work through this. So magnesium, I see magnesium, and then I see an SO3, okay? You're never going to have 3 elements separately, so it's always going to be half and half. So being able to kind of see that positive negative difference is really important here. So Mg, we know it to be in group 2, it's a +2 charge, and then you want to use your polyatomic list to find something that has an SO3 in it, because it's going to have a charge. So if I look at my list, it's at the bottom of that polyatomic anions page, and it is an SO3 -2 charge, okay? So now that you figure that out, you can go ahead and crisscross your charges. Again, you don't need to show that. But the name of this is, actually I need to write the whole word, is magnesium. And that is going to be sulfite. Okay, so you do not have to change any endings. You literally just write it as it's seen on that polyatomic list. Okay, only the previous one did you have to change that ending to "ide." This you do not change. You just write it as is. So Ca, and again that 2 came from here, and the reason why I'm talking you through that is because we will see this with transition metals. So Ca is a +2, and then Cn, that is cyanide, so we have calcium, cyanide. Now you're going to say, oh, this has an IDE ending. Yes, it does, Okay, and again, all we did was take that off the periodic table or the polyatomic list. All right, so it doesn't matter the ending. If it's on that list, you just write it as is. So this is aluminum. And then we need something with a CO3 and a -2 charge, which came down here. That is carbonate. All right, now this one looks a little bit overwhelming here, but you still need to keep in mind the difference of a cation and an anion. So this NH4 is actually the cation or the positive charge, and you can verify that on your polyatomic list on your equation page. So the NH4 has a +1 charge, and again, it's always helpful to rewrite these separately. And then that SO4 has a -2 charge. That is sulfate. So we're going to go ahead and name that ammonium sulfate. Now, while I'm here, I actually want to do one example with a transition metal, so I'm going to go ahead and throw another example down here at the bottom. So let's say we have FePO4, okay? FePO4. So Fe is a transition metal, and so when you are writing the name of it, you need to use the Roman numerals. Now, a lot of students will see this and say, oh, hey, it's a 4. It's not, okay? It is not a 4. It is an Fe and it's a PO4, and that PO4 sticks together. That's a polyatomic. The only things that crisscross are the charges that can be found up above. So we're trying to figure out this X and Y value. All right, now, because no charges were crisscrossed or brought down, they probably canceled each other out, right? Because this 4 comes from, on your list, you can find it under the phosphate ions, it's actually a PO4 -3. So this -3 is my Y value, and since we did not see that 3 crisscross and come down, we have to assume the iron, the Fe, was a +3 charge. So again, you have to use your context clues to realize this is an iron 3 phosphate. Okay, just one more example with transition metals there. Now at this point, I have a mixed review on the next slide, so go ahead and you can pause the video and just try to do those on your own, and then I will scroll here in a moment and you can check your answers. So make sure if you need Roman numerals, you are providing them. So again, anything that is in that center section, the transition metals or tin or lead do require Roman numerals, and things that are not, their fixed charges do not require.